Good, Sunita. In simple linear regressions, we completed and we built the model, search some work on form. No problem, no problem. The one who not completed yet, please complete soon. And you no need to post all the proof. Just you mention completed. All right. I can understand. No problem, guys. Yesterday, we built simple linear regressions. I hope you understand the logic behind all the concepts. Shekhar, you completed? You completed, buddy? Yeah? All right. So I hope you understand how exactly simple linear model works and what exactly the math concepts behind each and every algorithms. Clear? Today, I wanted to speak, I think just one moment, I'll explain this link, which is called house price predictions. In our batch, some of clever students are there. Even though does not shared, they find out and they complete the task. Good job. I mean, I think these guys have in 10th grade or +2, definitely they do make cheats, it seems. Just one moment. Please get it. Excuse me. Okay, so using simple linear regressions model, we need to predict housing price, right, guys? So this data set I have, all right, I don't want to, I think I explained yesterday data. So these are the columns we have, and you need to import. Let me show you again. I think I already downloaded the data before I go to the feature selections. Yes. Okay. Team, did you see the data set over here? ID, date, house price, number of bedrooms, bathrooms, square feet living, floors, waterfront, view, conditions, grade. Don't you think it looks like a latitude, longitude, square feet living? My simple questions, can I apply simple linear regressions over here? Yes or not? So what could be the dependent variable, guys? Price is the dependent variable. Yes. What is the independent variable? What is the independent variable? Square feet living. Yes, because 1180 square feet. So how do I take one dependent, one independent from across the data? So I hope these attributes are quite understanding. So no need to spend more time on these attributes. Yes, guys. So what I'm going to do, let me directly jump into the projects and NumPy Pandas, right, guys? Matplotlib. I import the data set. Agree? I import the data set. Space means what? Independent or dependent? Space. This is independent variable. Price is dependent variable. Agree? So now reshape, you know this, train test split 1/3 means how many testing sample? What's the testing percentages? 75, right? Now sklearn.linear model, import linear regressions and build the model. This is the predictions. Very simple projects. So what exactly the project name? Using simple linear regressions, we are predicting housing prices. Agree? Yeah. So please. So I hope you can work today, and some of them are completed. That's okay. No need to worry. The one who not completed, please do it today. I'll share the link in today's sessions. Okay. Yes. Let me close this. Let me close this. Before I start multiple linear regression algorithms, I wanted to introduce one concept called feature selection techniques. What exactly this? Feature selection techniques. Let me show you. Okay. In feature selection techniques, we have three methods, guys. What is the methods? This is straight short interview questions. So let me tell you, never ever confuse with these questions, which make you confused all the time. Yeah, just one moment. 13. Feature scaling versus feature selections versus feature engineering. So never ever confuse. What is the scaling techniques we saw? What is the scaling techniques, guys? Normalization and standardizations, right? So this is called normalizations and standardizations. We called as feature scaling. So you know the feature I called scaling, right? What exactly selections? In selections, we have three methods. The first one is called filter methods, wrapper methods, and embedded methods. This is data mining concepts. What is this? Filter method, wrapper method. I'll show you practical, but at this moment, just okay. Embedded method. So this is called selection, feature selection techniques. And this is a data mining concepts, right? In interview, if someone asks, this is theoretically you have to address to the interviewer, but practically what we are doing in the organizations, we called as backward eliminations. What we call backward eliminations. And I'll show next week on Monday, I will show you the multiple linear regressions. And this backward eliminations, we're going to learn using statsmodel.api, all those things. So we're going to do called statsmodel.api. I hope you understand, guys. Clear? We have 21 columns, but why we use price and columns? Very good questions, Rihan. Now, Rihan, you're going to buy a house, right? Once you pay the price to the builder, your house is yours, isn't it, Rihan? So can I say price is dependent variable? Agree? Correct or not? Because we take multiple variables, but at this moment, what is the equation? Y equal to mx plus c. So x is independent, which is square feet living, y equal to price. But if I considered all the attributes, I have other projects using multiple. You understand at that time. Clear? Yes, Rihan, I hope you understand. Cool. All right. So in this case, let's do this. So let's understand one by one. What is filter, what is wrapper, what is embedded, all those things. Feature selection techniques, this is the data mining concepts, okay? But practically, we use backward eliminations for recursive feature eliminations. We called as RF, okay? RFE. RFE means recursive feature eliminations. So in the data set, in the database, we have 1,000 attributes, right? So student's roll number cannot decide student passed the exam or fail. So that's an irrelevant attribute. But how do we identify that? One case is business. Let's understand. But other one, technical, we called RFE, recursive feature eliminations. Very, very important steps in data science journey. Understand? Now, let me explain you. In filter method, we have IG, means information's gain. What is this? Information's gain. Chi-square test. correlation coefficients. This is called filter methods, right? In wrapper methods, we have RFE. I told you, right? Practically, we use this on real time. In company, in organizations, heavily we use this one, and I'm going to show a practical on Monday. All right. Genetic algorithms, guys. You know, guys, I hope you guys are BTech students, some of them. They teach, theoretically, they'll teach genetic algorithms, right? But practically, we haven't used this. Understand? Practically, we haven't used this embedded method decision tree. So information's gain, and I explain later, means I have a algorithms called decision tree. In decision tree, we have a concepts called information's gain, gene index, entropy. All those things I will talk about later. So this one part I'll explain later. Chi-square test, we not using, but still I'll explain you what exactly mean by chi-square test. Correlation coefficients. Have we done this? Completed or not? What is positive correlations? What is negative correlations? What is zero correlations? We completed this part. Clear? So in filter method, if I explain chi-square test, then informations again, I'll talk to you later part. Now wrapper method, recursive feature eliminations. I will show you practical today and tomorrow on Monday, right? Genetic algorithm, skip it, not required. Understand? Embedded method, decision tree. I will tell you when decision tree we're going to start. So at this moment, I will tell three. What exactly mean by filter method? Let's understand. So guys, I have 1, 2, 3, 4, 5, 6. T means target variable. Online team, are you understanding? Yes, guys. T means target variable. A, B, C, D, E means non-target variable, right, guys? All the time, build the model with relevant attribute. Means filter means what? Out of 500 independent variable, if I filter and remove 200 attributes, so you build the model with 300 attributes plus target. This is called filter method. Understand or not? This concept is called multi-collinearity. What is this? Let me write down here. In interview, they will ask. I hope I send one question bank to you. Did you see this, guys? How to check? Not this one. How to check multi-collinearity? What is meant by multi-collinearity? Means in filter method, we have three concepts: information's gain and chi-square test, and what else? Correlation coefficient. Yes, correlation coefficient. Okay, so this is filter method. So what exactly filter method means? FM means always need to build with relevant attributes. If not, then what problem comes up? Maybe overfitting. Then multi-collinearity problem will arise. Understand? Problem will rise. Understand, guys? Yes, what is meant by multi-collinearity? Now, information's gain, I'll explain you later. So let's talk about what is chi-square test. So what exactly mean by chi-square test? See this formula, G equals to X minus mu divided by standard variable. So in this case, let's understand, where do you see this formula? Did you remember? No. Previous one? G test? No. G test or G score? Understand or not? Yeah. So now, guys, I'll give you one small example. Table shows number of aircraft accidents occurred in driving days of a week. Test whether accidents are uniformly distributed or not. Understand? So let's number of accidents. Monday, 14 accidents we had. Tuesday, 18. Wednesday, 12. Thursday, 11. Friday, 15. Saturday 14, Sunday 14, isn't it? Now the question is given DF, degree of freedom is 6, and X square at 95% confident, 0.05 means what? 5% not confident, right? So the accident value is 12.592. So this is the questions, and you need to test this use case with the help of chi-square test. Understand? This is also called as Pearson correlation. What we called? Pearson correlations. So let me write down. Chi-square test, also called as Pearson correlations. And this is which formula? G-score. They implement G-score formula. Clear, guys? So remember, guys, these technical point is very important. I'm sure you're going to get an interview in future days. Understand? So here, now how to how to address this use case? Whether the accidents are uniformly distributed or not, this is a use case. Now let's do this. If I add all the accidents, total 98, right? Yes or not? So 7 days in a week. So 98 by 7 equals to 14. Agree or not? 98 by 7 equals to 14. So this is observed value. This is actual value. So observed values are 14, 18, 12, 11, 15, 14, 14. Expected values are 14, 14, 14. This is a constant because this is the chi-square test formula, guys. This is the chi-square test formula. Now, when I implement, when you troubleshoot this equations, 14 minus 14, 18 minus 14, and finally you get the value. Yeah, it will check X square is less than X square. If this condition is satisfied, the hypothesis is accepted. Means in the questions, what is the X square we got? So let me tell you, question given 12.592, right? This is 12.592, but based on the chi-square test, I think I got some value over here. Let me 2.14, right? The value is 2.14. Look at this, guys. This is called 2.14, right? So can I say 2.14 is less than 12.592? Agree or not? On this case, the hypothesis is accepted, and this type of distributions we called as uniformly distributed. The use cases we done using chi-square test. Okay. Maximum you don't ask in interview, but I already explained. At least you can speak something about it. Okay. Yes, guys. Online team, are you understanding? Yes, Washim, Sushma, Jade, everybody. Okay, let's close this. Filter method, I hope you understand, because students roll number 1 pass the exam. Relevant or irrelevant? This is irrelevant attribute. You cannot build the model with irrelevant attribute. So filter method, please. Filter methods we completed. Okay. Yes, guys. Now the next one. Yeah. So the next one, let me explain the wrapper method. What exactly mean by wrap? You know, guys, wrap the music means what? When you combine all the mix the musics, yeah, that's called wrap. Means in this data set, I build the model with attribute A and T. I build one model we called M. Understand? Next step, I build another model with A, B, and T. Understand? So this is M2. That was M1. This is M2. I build the model, right? So model M1 has different accuracy. Can we get different accuracy or not? Now the second step, I build the model with A, B, C, and T, M3. So how many model I can build like this? Multi models we build. So, but when I implementations on real time, does it takes more time or not? This is notly we're gonna implement. So did you see this? Attribute with A and T. I build a model M1, A, B, and T, M2, AC, and 3, M3, and we're gonna build multiple models like that. This is called wrapper methods. I hope you understand, guys. But in wrapper methods, we have two type of things. One is called recursive feature eliminations. How we do a backward eliminations, I will explain on practically. Okay, we understand something like that. All right, guys. The next part is what we have. Yeah, decision tree anyway, I'll cover up. This is called embedded methods. So understand these feature selection techniques. Remind me after next week, just remind me guys, anyone, next week I'll give or complete feature selections code. All right, just you can remind me. So that's why I mentioned over here. Correct. Now today I'm going to start another algorithms called multiple linear regressions, right? What exactly I mean by multiple linear regressions? Y equals to m1 x1 plus m2 x2 plus m3 x3. Understand? So this is multiple model. So now I will show you one data set today. I'll explain one data set. In this data set, we will work on two use case. The first use case, we build the model using MLR, multiple linear regressions. Then we implement statistics. We learn statistics, right? Inferential statistics, G-test, T-test, ANOVA, all those things theoretically we learned. I will show practically, then we will understand practical for all inferential starts with backward eliminations, which we called as RFE, recursive feature eliminations. Team, are you understanding or not? Online team. So let's go ahead and then we go ahead for project is called house price prediction using multiple linear regressions with RFE. Understand? Clear, guys? Okay, now let me explain this one. Just 1 second. Okay, so let me open one data set. See guys, how many attributes I have over here? Okay, now I'll create some business storytelling tips from this data set. What exactly the use case of this data set is? The first thing, let me tell you, a lot of things we're going to understand from this data. Let's say a company, a IT company, all right, or maybe software company hires you as a data scientist. Okay, hires you as a data scientist, and the manager gave this data set to you. What is the data set? This is the data set, right? This is the data sets, they gave it to you. So what he want from you is, that's why you're getting paid, right? So what he want from you, let's say, first understand this data set. This is a startup company. Okay, what exactly? This is the startup company. So in the startup company, if that company R&D means what? Research and development. 165 millions he spent in R&D. 136 is spent in administrations. 471 he spent in marketing spend for New York State. And he gaining a profit of 192. Understand? Team, everybody's understand or not? Same things. If a company spend 153 on R&D, 101 on admin, and 407 on marketing for Florida, he got profit of 191. Understand or not? Yes, Chandrahas. So now, due to COVID, okay, due to COVID, he don't have this much of money to spend. Understand? Due to COVID, he don't want to spend on 1, 2, 3 departments, right? So he called you and he had a meeting with you stating, you need to suggest me only one attributes. What is the problem statement? The problem statement is data scientist need to suggest business about which one attribute or which one department company need to invest the money. Guys, I hope you understand or not. Clear what exactly the use case? So now in this scenario, so let's look at this. What exactly the dependent variable here? Anybody? So let's copy and one moment. Also, no. So profit, right? Everybody's agree or not? Profit. Now let's copy this and okay, guys. So profit is column. It's a regressions or classification. Why, guys? Why it is regressions? Dependent variable is continuous. So can I fit my equations like this? Y, just one moment. So y is equals to x1 plus x2 plus x3 plus x4. Can I fit my equations like this? Agree or not? Yeah. In this case, which one is missing? M1, M anyway you will generate from the package. But which one is missing? C is missing. What is meant by C? Intercept means no coefficient. Intercept means constant, right? Constant. So what exactly mean by constant? Let's say 3 by 2 equals to 3 by 1 into 1 by 2. Which one is constant over here? Which one is constant over here? 1. 0 is, can I take 0 as a constant? No, right? I hope you guys are aware of in the school grades, right? So 3 by 2 equal to 3 by 1 into 1 by 2. So 1 is a constant. So what I'm going to do, can I add attributes called constant? And I'll mention 1 to all of the columns. Now, can I fit into my equations? Can I fit this into equations? Yes or not? So for example, y equal to m1 x1. M1, I'm going to get slope from R&D. M2 x2 plus M3 x3 plus M4 x4 plus constant. Now, can I call this as a multiple linear regressions? Agreed or not? The first problem statement, we're going to build MLR, multiple linear regressions. The second statement, we will suggest to the business where company need to invest the money to gain a profit. I hope you understand, guys. Clear or not? Online team, are you understand? Okay, so let's do this and build the model. I'll divide these sections into 2 parts. Today, I will complete 1 sections. On Monday, I will complete these sections. All right. So let's do this. Just 1 second. Right. So .py. Okay. So yes, the first one is NumPy, Pandas, Matplotlib. Yes. So let me run this one. And I think I need to change my path because that was the path which is not available, it seems. So what I'm gonna do, I just change the path. So when I change the path, just do it here. Do we have any missing values? Let's check. No missing values, right? So 0 means there is no investment is done. Understand? So this is called 0. So I hope you understand this part is done. Now, how do I split my data? Dataset.ilog profit is dependent variable. Agree? So if I remove this becomes independent. If I remove all the 4, then this becomes my what exactly? Independent variable. X equals to dataset.ilog from the first index to the last index and remove -1 from the backward indexing. So let me done this. X is ready and Y datasets.ilog. Very simple. Guys, are you understand or not? Yes, I mean, I split the data into independent variable and dependent variable. Clear or not? Yes, understand? So where you see the text data, X or Y, where do you see the text data? X or Y? X. So can we impute this or not? Can we impute this or not? So how do I impute this? Very simple. Look at this code, one line of code. X equals to, what is meant by PD? Pandas dot get a dummy. What is meant by dummy variable trap? In this moment, in X, I have how many columns? Look at this. 1, 2, 3, 4. Isn't it? Isn't it? Now I would say get underscore dummies. I pass X2 over here and let me execute. Done this. 6. Check this out. Guys, are you understand or not? So what happened? Over to New York, New York 1, California, California 1, and Florida, Florida 1. Understand? 3 classes has classified into 3 classifier, right? So what is the 3 classes? NY, CA, and FL. It has been classified into 3 classifiers, guys. 1, 2, 3. Clear, guys? I hope you understand. As I saying, feature scaling does not required on this case because the output is number. So feature scaling is not required. Directly, what I'm going to do, I split the data into training testing phase. What exactly this? Train test split. And assume I'm going to split with 2 part. One is called train test split and 20% test size. I could take it. So let me call the package train test split. All right. Sunita, see, you can use, but at this moment you can use, but I would say please work on the code. Once you understand, you can know which one, which when needs to use. Last code we used label encoder, but also you need to understand, right, where to use dummy variable or not. If you use continuously one code, it's not make sense. Yes, Sunita, understand or not? So here test size I've been considered as 20%. So out of 50, what could be the 20 percentages, guys? I think train test split I imported 10. Excellent. So 50 records is classified into 40 training, 10 testing. Agree? Very simple. For multiple linear regressions also, what package we have? Linear regressions only. See guys, linear regressions consists of both simple and multiple. Understand? So here, sklearn.linear model import linear regressions. So that means when I import linear regressions, means what? The formula, what formula? Y equal to mx plus c. This formula has called from backend, I hope you understand. So we understand this formula to clear the interview, but for practical, just work with the packages. Just work with the packages. Team, are you understanding? Yes or not? Are you understand or not, guys? The one very simple, let me build the model over here, and linear regressions, this is called linear regressions. I called a variable regressions, and let me fit this model. How to train the model? X train and Y train. So let me train the model with X train and Y train. Then I create a predictions part. Regressors. What is meant by regressors? Regressors is hold linear regression algorithms, right? Look at this, my cursor. Regressor hold simple multiple linear regressions algorithms. I mean both. So here predict X test. When I predict X test, just compare to whom I need to compare Y test with Y predicted, right? See, actual profit is 103, but my model also predicted 103, right guys? Actual profit is 144. The model is predicted 132. Yes, guys, I hope you understand. I told you what is the performance measures in regressions? R square, adjusted R squares. We need to see practical or not? Yes, guys, we need to see practical. How do I get R squares from here? This is a multiple regressions model. Yes, we need to understand what exactly mean by R square and adjusted R squares. Clear? The thing is, let me predict X test. I think we build this one, X train, Y train. No, turn this one. When we, just 1 second. Did I explain when we call low bias and low variance? No. Just one moment. Just 1 sec. Okay. I'll explain on classifications, not at this moment. That's okay, leave it. One moment, guys. Just 1 sec. Okay, we have Y test and X test. That's okay. Just give me 2 seconds. I'm checking something. Okay, score is not attributes. Okay. All right, 93 percentages. Okay, so now let's see this. I think we understand. So far what we done is, so far just ignore at this moment. I'll talk to you later. Yeah. So actually what we done, we build the multiple linear regressions model. I hope you understand. So now what exactly the business use case? What is the use case, guys? Total, how many attributes I have in the data set? R&D spend, admin spend, and marketing spend. So the CEO ask, you have to suggest to the business guys, right? Which attributes you need to invest the money. So how do you do this? For that concepts, I wanted to introduce a, see guys, I have to remove or not? I have to show practically to the business guys. If you say you can spend R&D, you need to give a proof why you need to do R&D, isn't it, guys? If you say admin, you have to give a proof. For marketing, you have a proof. So what proof you have, guys? At this moment, you cannot say blindly, isn't it? So that's why I wanted to introduce a package called statsmodel.api. What exactly mean by that? Stats model dot API. What exactly mean by API? You know, from the all the school colleges, whatever the formulas we have, let me show you. Stats model dot formula dot API, right? Let me open this. Stats model. So in this one, if you notice this, guys, what happened? Regressions, right? In regressions, what we understand, OLS. Have we learned OLS or not? We have you learned WLS? No. GLS not required. All right. The one who is statisticians, for them it is required. Understand? So for us, we required OLS. In OLS, what parameters we have? Ndog and Xdog means feed in, feed out, means eliminate the variable. When I enter dummy variable to the data set, means I had 4 attributes before, right? After I create a dummy variable, this 4 has turned down to 6. Agree or not? I mean, I just add the more features to the data. So how to find out which attribute is important? I have to remove some features or not. To remove the features, we have a concept called XOR. Yes, I hope you understand. So recursive, ndog, xdog, imputations. See, all the formulas, guys, like statistics formulas has club the starts model.api. So this is the powerful tool. You just call starts model.formula.api. All the formula is called in the backend. I hope you understand. Yes, online guys. Yes, team. But you know it to what is log it, prob it, everything's I'll talk to you. It's not your job. You not going to do a research. Are you going to do a research, guys? When you want to do research, when your college days, you want to do research. So all this is good for a research, but at this moment, I just wanted to show you what exactly mean by starts API. I hope you understand. Dot API is how do you declare it? Import starts model dot API as SM. Remember this. Clear? Guys, are you understand or not? Yes, online team, offline as well. Import starts model dot API as SM. The same thing I've been called here. Import starts model dot formula dot API as SM. Guys, are you understanding or not? Why I call it starts model? Why I call this a start model? All right. So let me execute this one first. I call this in this data set. Let me right. So this is so what I can say. This is x1, x2, x3, or x4, x5, x6. Right? 1, 2, 3, 4, 5, 6. Which one is missing? Which one is missing over here? Constant is missing or not? Y equal to mx1, mx2, mx3. So I want to add 1 to 50 rows. Agree or not? Yes, guys. So how to add? To add 1, we need to append functions, right? Yes. Yes, Sunita. X. I want to add in independent variable only, not dependent. np.append, np numpy array equals to np once 50 rows comma 1 as type integer. Do you need a float? No, we don't want dot as type. Do you know, guys, from categorical to object we change it on one of the sessions. Values equal to x is 1 means what is meant by x is 1? Column names, right? X is 1 means column names. Now let me execute this and see this again. Guys, are you understanding or not? This is constant now, plus x1 plus x2 plus x3 plus x4 plus x5 plus x6. Team, are you understanding or not? So what is the indexes? 0, 1, 2, 3, 4, 5. 0 index means constant. First index means R&D. Second index means admin. Third index means marketing. 4 means dummy variable 1. 5 means dummy variable 2. 6 means dummy variable 3. Now, let me define the same things. Import starts model.api.as sm 0, 1, 2, 3, 4, 5. Guys, are you understanding or not? Guys, are you understanding or not? Yeah. So in this case, in this case, 0 means what? Constant. 1 means what? R&D. Let's do this. I'll create a variable ndog xdog, right? So I created an optimal value, execute this one, right? Now guys, regressions.ols. Just now, I show you the formula, right? Copy this and I paste over here. Regressions.ols. SM means what? Starts model. OLS. Ndog means what? Y means what, guys? Dependent variable. Xdog means X opt. The value should dot fit the model. Let's see this. Run and summary. This is called regressions table. I hope you understand, guys. Yeah. Now tell me, guys, is it a good model or bad model? Did you see this? What is this table called? OLS regressions table, right? This table is generated from the data set, right? So in this case, do you remember one conditions I told? R square is greater than adjusted R square. The model is a good model. What is the R squared value? 0.95 is greater than 0.94. Good model we build. Guys, are you understanding? So all the time you check this. Statistics, whatever the statistics we learned, I am going to show you practical now. Dependent variable is what? What is dependent variable? Profit. You got this. Model OLS, right? Ordinary least square. Method least square. We run this code on Friday, 13th May at 10:57. Isn't it? Now, what is the total number of observations? What we called these 3 steps. Anybody remember? What is ANOVA? Analysis of variance. Number of observations. Washim, what we call this? SST. Guys, are you understanding? SST, residual, SSR. Correct? I hope you understand, guys. This is DF of the model 5 because we don't find any error. So that's why you haven't called SSC. Are you understand or not? What is meant by covariance time non-robust? Means this is not a constant model. When I execute next time, this values will change. I hope you understand. This value will change. That's what we called as a non-robust. Clear? Now, understand, guys, up to this or not? I don't know how many of them understand offline. I see that 40% are not understanding, guys. You are here, but your mind is somewhere else. It's up to you, guys. It's again, I'm saying, a lot of them feeling sleepy because you don't understand. Let me tell you, I can see the face. I don't point out. This is not sounds good. We are not a small kid, guys. We are here to study. Understand this one. You are here, but your mind is not in the sessions. Let me tell you. So in this case, online team, are you understanding? So here, F statistics, probability, log likelihood, not required all these 3 things at this moment, right? Now come back to this part. Come back to this part, guys. Come back to this part. The first one, t-test. Why we call t-test? Because the data set is a sample. Got it. Standard error. Do you know standard error? What is the standard error, guys? Maybe whatever the formula we have. Yeah. Now, p-value. What is the p-value? You know the significance value, right? Constant means what? Constant means 0. Agree? X1 means first index. X2 means second. X3 means third. X4 means 4. X5 means 5. I hope you understand. Now, yeah, standard deviations by square root of n. Good, Sunita. So in this case, coefficient of constant is 5.0 something. Coefficient of R&D is 0.80. Coefficient of admin is minus 0.02. Coefficient of X3 is 0.02. Coefficient dummy variable is 41. Dummy variable is 240. Guys, are you understanding? In this case, where do you see highest p-value, guys? Where do you see the highest p-value? Which index? X5 p-value, X5 or X4? X4. Yeah. What is the conditions? The condition is if p-value is greater than significance value, means let's assume the significant value is 0.05. Okay, guys. So because who gave this values? This is statisticians has assigned this value. Now, can you say 0.990 is greater than 0.05? Agree or not? If the p-value is greater than significance level, then we reject the null hypothesis. So let me tell you, if the p-value is greater than significance level, then we reject the null hypothesis. In statistics term, or we eliminate the feature. I hope you understand what we do. This is called RFE, recursive feature eliminations. So let me tell you how to do this. Online team, I hope you're understanding. Yes, guys. So let me do it in this scenario. How do I eliminate these features? 0, 1, 2. Which one? X4 means which value, guys, over here? 4 or 5? 4, right? 4 or 5. So can we eliminate this feature? Okay, before that, this is probability, all those things, curtoise, skewness, everything will get. Now let's copy entire code. Okay, what I'm do? Let's copy entire code and let's paste here. I remove 4. See this 0, 1, 2, 3, 4, 5. Do you find 4 is there? No. Let me build the stats model again. One feature is eliminate. Let's do this. 0.994 is eliminate or not, guys? I hope you understand. Clear or not clear? See this. 995 is no more over there. X5, now X4. Guys, are you understanding or not? What exactly I done? One features I remove the concept of XOG. I hope you're clear. Team, are you understanding? I know, guys, very few people are understanding. I know that who are understanding, who is not. No problem. Again, I'll explain this one on Monday because 11 o'clock, some of the, for 9 to 10 days, I will log out at 11:05, 11:10. All right, guys, because some of the session is going on, online team. Some of the demo, full stack, Java, something is there. It's going on. And after that, we'll continue like 20, something like that. All right. So are you understanding? Up to this clear or not? Up to this clear or not? How do I remove the features? Still, I have to remove many features. Still, I have to remove many features, guys. So what is the next p-value? X4. X4 means what part we have over here? I will tell you, when you practical on your system, take a pen and paper, write down 0 means constant so that you won't confuse. Okay, guys? All right. Now, I wanted to explain, I want to show you, see guys, just one sec, just one moment, why it's taking more time. Oops, come on. So I think you have some work for this week. Okay, guys, and simple linear regressions you complete. And also, I think I'll share this one, 12th class. And also, can I share MLR, guys, multiple linear regressions? Will you build? Okay. And if possible, I'll give this one also, multiple linear regressions, house price predictions using multiple linear regressions. But please share 9th, 10th class document to 9th, 10th already shared data pre-processing. 9th, 10th not shared. Yeah, I'm sending. Okay, Sunita, I sent. And I just wanted to show up. I gave you the Python book task. Are you guys working on it? No. Let me show you. I create a folder, something like this. I just wanted to highlight today. I think it's taking some time, man. Jupyter. Why? Let's do this. Okay, what else you want? Tell me. I send this one. No. Completed are posted in classroom. Very good, Sinduri. Sinduri, I understand. Okay, you post in the classroom. Remind me on Monday. We will do it. Okay, Sinduri? Yeah. Remind me on Monday, Sinduri. We will do it in the classroom. Right. I just wanted to show it's getting response too late. Don't forget to tell this. Okay. How many pages you completed? May I know, please? How many pages you assigned and how many pages you completed? Oops, I'm not getting it. We'll discuss on Monday. Okay, Sinduri? We will discuss on Monday. Okay. So I will share this code and also I will explain on the sessions because I have ten AM 13th. All right. So 13th also I will share. Whatever pending will complete on Monday. And yeah, in recursive feature eliminations projects also there. And I will send this one as well, project list. This part. Polynomial regressions algorithms. I don't want this at this moment. Control S.